Alright, so in this problem, I have 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And I actually have 4 answer choices for this problem. So for answer choice A, I have 27 to the power of 30. For answer choice B, I have 9 to the power of 30. For answer choice C, I have 27 to the power of 10. And finally, for answer choice D, I have 3 to the power of 21. So we want to figure out which one of these answer choices is the correct answer to this problem. So let's go ahead and test out each of the methods used to solve out these problems and figure out which one is right. So for 27 to the power of 30, how you obtain this solution is you simply add all of the bases and the exponents. So the bases are all 9, so you do 9 plus 9 plus 9 to the power of, and the exponents are 10. So you do 10 plus 10 plus 10, which is equal to 9 plus 9 plus 9 is the same thing as 9 times 3, which is 27. And 10 plus 10 plus 10 is the same thing as 10 times 3, which is 30. So you get 27 to the power of 3 using this method. 27 to the power of 30 using this method. However, this method is actually wrong. This is not the right way of adding exponents. You can't just add the bases and add the exponents. Now, for the second way, what you have to do to get this is you actually, this time, you keep the base the same and you simply just add the exponents. So you do 9 to the power of 10 plus 10 plus 10. Now, this is equal to 9 to the power of 10 plus 10 plus 10. Again, that's the same thing as 10 times 3, which is 30. And again, this method is wrong as well. That's not the correct way of adding exponents. So now for the third method, C, what you have to do to get this is this time you add the bases and keep the exponent the same. So you do 9 plus 9 plus 9 to the power of 10. And this is the same thing as 9 plus 9 plus 9 is the same thing as 9 times 3, which is 27. So you have 27 to the power of 10. And this method is wrong as well. That's not the right way to add exponents. Finally, we have D. And to get this, the first thing you do is you can write this as 3 times 9 to the power of 10, because 9 to the power of 10 plus itself 3 times. Now 9 to the power of 10, that's the same thing as 3 to the power of 2 to the power of 10, because 9 is the same thing as 3 to the power of 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of 10, that's equal to 3 to the power of 2 times 10, which is the same thing as 3 to the power of 20. So now I have 3 to the power of 1 times 3 to the power of 20, and this is equal to 3 to the power of 21. And this is actually the correct way of solving this problem. So the right answer is D. Alright, so in this problem, I have x to the power of x to the power of 3 is equal to 36. So I want to find the value of x here. So for my solution, first start with x to the power of x to the power of 3 is equal to 36. Now, I'm going to take the power of 3 on both sides. So now I have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And m and n, these two are interchangeable, meaning I can also write this as a to the power of n times m. And if I can write a to the power of m times n as a to the power of m to the power of n, then this means that I can write a to the power of n times m as a to the power of n to the power of m. So in this case, I have x to the power of x to the power of 3 to the power of 3, and we can think of x to the power of 3 as m and 3 as n. So if I switch these two places, I get x to the power of 3 to the power of x to the power of 3 is equal to 36 to the power of 3. Now 36 I can write as 6 to the power of 2. So now I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 2 to the power of 3. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 6 to the power of 2 to the power of 3, that's going to equal 6 to the power of 2 times 3, which is simply 6 to the power of 6. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, x to the power of 3 is equal to 6. Now, I'm going to take the cube root on both sides. So now I have the cube root of x to the power of 3 is equal to the cube root of 6. Now, the cube root of x to the power of 3 is simply x is equal to the cube root of 6 is the same thing as 6 to the power of 1 over 3. So this is my answer. So now to check, I have x to the power of x to the power of 3 equals 36. We know that x equals 6 to the power of 1/3. So now I have 6 to the power of 1/3 to the power of 6 to the power of 1/3 to the power of 3 is equal to 36. Now 1/3 and 3, these two cancel out. So now I'll be left with 6 to the power of 1/3 to the power of 6 is equal to 36. Now 1/3 times 6 is 2. So now I have 6 to the power of 2 is equal to 36. And 6 to the power of 2 is 36. So if 36 equals 36, and because this is right, my solution is right. Alright, so in this problem, I have x to the power of 4 minus 16 is equal to 0. So to solve this, I'm going to first rewrite x to the power of 4 as x to the power of 2 times 2. So now I have x to the power of 2 times 2 minus 16 is equal to 0. Now 16 I can rewrite as 4 to the power of 2. So now I have x to the power of 2 times 2 minus 4 to the power of 2 is equal to 0. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, x to the power of 2 times 2, I can rewrite as x to the power of 2 to the power of 2 minus 4 to the power of 2 is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to x to the power of 2 and b is equal to 4. So I have x to the power of 2 plus 4 times x to the power of 2 minus 4. And this is equal to 0. So now x to the power of 2 minus 4, this is actually the same thing as x plus 2 times x minus 2. So now I have x to the power of 2 plus 4 times x plus 2 times x minus 2 is equal to 0. So now this gives me three equations. I have x to the power of 2 plus 4 is equal to 0, x plus 2 is equal to 0, and x minus 2 is equal to 0. So for x minus 2 equals 0, all I have to do is add 2 on both sides. These two cancel out, and I'll be left with x is equal to 2. So this is one solution. For x plus 2 equals 0, I have to subtract 2 on both sides, and I get x is equal to negative 2. So this is my second solution. And finally, for x to the power of 2 plus 4 equals 0, well, I'm going to subtract 4 on both sides. So now I'll have x squared is equal to negative 4. Now, if I take the square root on both sides, I get the square root of x squared is equal to the square root of negative 4. The square root of x squared is x. And the square root of negative 4 I can rewrite as the square root of 4 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So now I have x is equal to, the square root of 4 is equal to positive or negative 2, and the square root of negative 1 is I, so I have x is equal to positive or negative 2i. So my four solutions here are x is equal to positive 2, x is equal to negative 2, x is equal to positive 2i, and finally, x is equal to negative 2i. So these are my four solutions to this problem.